Yes, hi everyone. This is the first talk here at the Kotlin Dev Room. It's the first time for me at FOSDEM, so a little bit excited about that as well. My name is Eric Hellman. I am working as a freelance software developer back home in Stockholm, Sweden. I've been using Kotlin for quite some time, but mostly I've been doing Android development for the last couple of years. So this talk is about coroutines with Android. I'm not going to go into the very deep coroutine parts. There are going to be plenty of those talks here today. This is about how do you use coroutines on Android efficiently and in a smart way. So just quick raise of hands. How many here do any Android development? Almost everyone. That's nice. Okay, so that will be useful, hopefully. Let's do one more. How many here use coroutines in their Android applications? A little bit less. Okay, good. I picked the right topic. So you can find more information about me, some of the source code I am showing today on my GitHub account. I have a blog post that covers part of what I'm going to talk about today. But most of all, on speakerdeck/Eric Hellman, Eric with a K, you will find these slides already. I've uploaded them there. So yeah, let's get started. So you probably heard this one before. Kotlin coroutines are lightweight threads. That's how JetBrains describes it themselves. But what does it really mean? For those of you who have been using it, you know that it's very easy and cheap to start a coroutine. It doesn't cost very much compared to starting a thread. So they have a very good example that is not very useful in real life, but it looks something like this. Where you start 100,000 coroutines that just prints a little dot after waiting 1 second. And if you would do this using threads, your computer will grind to a halt and probably have to reboot it or something. But this will complete in a little bit more than 1 second, because this will run in parallel in a smart way, as coroutines are. Hopefully there will be more information about how this coroutine stuff works during the day. For those of you who are more interested in the technical details. But suffice to say, coroutines are cheap, they're easy to use, it doesn't cost very much to start one. So, but the coroutine concept is not new. There are other languages that has that as well, like Go routines in Go, and well, Erlang has it, etc., etc. And it's a great way to run stuff in parallel or asynchronous. But Kotlin also adds something called structured concurrency on top of this, and that becomes very, very useful, especially in applications where you have life cycles that are shorter than the actual life cycle of the application, like the life cycle of a view, life cycle of a class that just is valid for a certain period of time during the use, etc. So structured concurrency builds upon the thing that any coroutine started needs to run within a scope. And the scope can then be connected to the life cycle. There is a great blog post by one of the Kotlin developers at the head of Kotlin, I think it is, Roman Elisarov. He works at JetBrains, where he talks about and writes about what structured concurrency is. This one is from 2018, and he wrote some follow-ups, but I recommend you read this blog post. So coroutines are always related to some local scope in your application, which is an entity with a limited lifetime, like a UI element. So the lifetime of a button or a fragment or activity is always shorter than the actual application lifecycle. But your coroutines will be started from those. So when they first started with coroutines, they didn't have the structured concurrency, so they didn't have the concept of scope. So you could do something like this, and it would be properly valid. This is deprecated. Do not use this today, mostly because you can't use it today because it probably won't compile anymore. But just launching a coroutine out of nowhere is not the way to do it, because then you might have things hanging, and the typical thing that you have in Android applications where you actually try to update the UI and you're not in a valid state anymore. So instead, there is this extension function. The first one that's most useful when you write your own suspending function called coroutine scope, which only can be used inside a coroutine scope. The coroutine scope is where the lifecycle management will happen. We don't really need to go into the details here. I'm going to talk a little bit about async in a moment. So, coroutine scope, what is it? Well, it's just an interface which has one public property, a coroutine context. The coroutine context is what runs the thread, the coroutine. It's actually the thing that manages it, tells you what dispatcher to run it on, etc., etc. And you can cancel all the coroutines that get launched by canceling this context. So that's nice. Now there is another bunch of extension functions added on top of the coroutine scope interface. For instance, launch. So launch says start a new coroutine for me. It has two optional parameters. First, you can give it a context if you want to, and that will be appended to the one it's running inside. And you can tell it how it should be started, if it should be started eagerly or lazily, etc. There will be more talk about what that means later today. And finally, you give it a function, a suspending function, which must be running inside the coroutine scope, and this one will basically be your code. So this is nothing you have to write yourself, it's already there, but it lets you run coroutines inside activities, fragments, any lifecycle component in Android, and they will be canceled accordingly at the appropriate time. So how does a cancel work? Let's go back to this. Let's start 100,000 coroutines, let them wait 1 second each, and once we have started all these 100,000 ones, we sleep for 100 milliseconds, and then we call cancel on the scope, which will mean that all of these 100,000 coroutines will be canceled. So, very theoretical example, but I hope you understand the concept there. Now, Android. All of you who have developed Android applications have probably seen one of these two images. I'm sorry for not being able to blow them up, but you know why, because it's impossible. These are horrible diagrams, and I hope that you don't need to look at them anymore, because thanks to the updates that Google has provided with us over the last 2 years with the Jetpack library, they are not really that important anymore. But we still have a life cycle, so how does it work? How do we take the life cycle in Android, and how do we combine it with a coroutine scope? Well, as I said, when to cancel is a question here, because that's the thing. You could write these coroutine scopes yourself, add them to your activity, your fragment, and then call cancel at the appropriate time, but that kind of like defeats the whole purpose. We would like to have something out of the box. So, Android Jetpack. So if you don't know what Android Jetpack is, I'm sorry, I'm not going to go into the details there, but these are the default libraries that you should use in any Android application today. There are a bunch of libraries that takes care of different things. In this case, we want the lifecycle libraries from the Jetpack libraries. So what we do, we add these dependencies, the lifecycle runtime, KTX, view model KTX, and live data KTX. It's important that you add the KTX to them, otherwise you're not getting the coroutine stuff. You will just get the standard stuff that doesn't have to do with Kotlin per se. These things I'm going to show today were added in 2.1.0, I think, or maybe 2.2.0 for some parts of it. But the latest stable version now is 2.2.0, so use that one. So the first extension function they added that is of interest of us is extension property. They basically just added a property getter on the lifecycle interface, which is called coroutine scope, which combines the lifecycle of a component, an Android component, an activity, a fragment, etc., with the coroutine scope that does all that job for us. You can read this code later. It's actually very simple once you have a look at it, but it basically stores a reference to this coroutine lifecycle coroutine scope inside an atomic reference class. That's part of the lifecycle class. So then it has another extension property on the lifecycle owner interface, which basically is your activity or your fragment. And this is the lifecycle scope, and it's just a getter that gets the coroutine scope from our other previous lifecycle coroutine scope. So these are the two things that enable coroutine lifecycle management automatically for us. So how does it work? Well, simple. Now you can just do something like this. We have a button. When you click the button, you want to log in. And then we call lifecycle scope the extension property that is available on activity and fragments. And you call launch there, which will start the coroutine. And now, asynchronously, it will do this, and you can call do login. Now, this is not the perfect way to do this because, well, for various reasons, probably do login wants to run on a different dispatcher, etc., but besides the point in this example. If you want to do coroutines in a view model, and there are reasons why you want to do it there instead, you can do that as well. So they have a lifecycle management for that. The view model class has onCleared function, which gets called once the view model is no longer used or no longer necessary to keep around. So what this extension property does is basically adding a coroutine scope that is getting canceled in the onCleared function for you. So now you can do view model scope.launch. This will allow you to do, like, not expose coroutines up to your UI components, which might or might not be a good idea. It depends. So first pattern or advice is to always use the lifecycle KTX libraries for Android when you're doing coroutines. Do not try to reinvent the wheel. Everything is there for you. It's getting proper testing, etc., as with any concurrency or threading or things like that, you don't want to reinvent stuff yourself. Now, where would you want to call launch for the stuff you're going to do? Well, you can call it in your fragment, in your UI, the top level UI component you have, like you have a login fragment. That might be a valid thing to do. But what happens if you would press back there or something? So maybe you want to move it down and you want to do launch your coroutines in your activity. Well, that might also be a good idea, but what happens if you press home or you leave the activity? So maybe a better choice is to add the suspending function in your view model, so it survives when the user goes in and out of that scope. Well, also the view model is also cleared, so maybe depending on what it is you want to do, maybe you should put it in the singleton object you have that is the repository for talking to your backend API. So it depends. You need to make these choices yourself, depending on the use of the APIs, etc. Just remember that how things are canceled is what will affect the completion of your coroutine. So you already saw async before in one of the first slides, and there's also launch. These are two of the basic ways of starting coroutines. So let's see the differences here, what they mean. So let's say we have our login API, which has a suspending function named login. Whatever we do there, it's besides the point. You might use retrofit or ktor or whatever, Firebase or something, but you get an auth result back. So in our fragment, we have a reference to our login API. So we call lifecycle scope.launch, we call login, we get the result, we check the result, and we do something there. This is perfectly valid. And it's also, it might actually be a good idea to use that one if you want to make sure that the user stays in the login fragment, and if they leave, you would actually cancel whatever login operation you had. Now, another way to do it is to use async. So when you call async and you return something from an async function, you're no longer getting a job, you're getting a deferred. So the deferred result, it's like a future in Java. What that means that you can take this deferred result and pass it into another coroutine elsewhere in your application. So in this case here, we just start two different coroutines, and the second one will wait the await call there will then suspend the function until the login operation is completed in the first coroutine. So again, which one should you use? It depends. I can't give you an answer that is 100% valid every time. So you have to consider what is your use case here. Maybe you want to take the deferred result and pass it on to another fragment. I don't know. So that is launch and async returns like a single result or do a single thing here. But what about streams of events? That's usually what we're working with today, whatever it's where it's coming from. It might be database, it might be outgoing events, might be incoming events, might be data coming from an API, etc., etc. It might be updates from your GPS. There are many types of events, and we treat them like streams these days. So if you know React, RxJava or something like that, you probably worked with that before. It's a nice pattern to work with, and we got that with coroutines as well. I'm not going to go into the details of reactive streams for Kotlin. I'm going to give you one example so you have a feeling of how to use it in an Android application. So instant search is probably familiar to most of you. You start typing, and for every letter you do, you make a new search query. So the challenge here for you as a developer is that you don't want to spam your API. So you don't actually want to call the search API on every single key press, because it would just be a waste of resources. So you want to have a certain threshold where you when the user stops typing after a certain amount of time, then you send a request. And if a new search happens while the old one is going on, you want to cancel the old one and make a new one. You get it? So that's the challenge with instant search. Now, this is an application that you can find on my GitHub. I'll show you a link to it later as well. But conceptually, it works like this. You have a stream of search queries going down into your application from your fragment into your view model, into your repository class, and away to the API. And then you have a stream of results coming, the search results coming back up to your application. So here you have two streams going in both directions. We start with our basic search repository. Just perform search, we get a query, we pass in a query, we get a list of strings back. Our view model has a query channel, and the query channel is of a type called conflated broadcast channel, which is a very strange word if you haven't worked with this before, but I will explain shortly what it means. What we do then is we publish a search result property. I see here that I didn't show the type of this search result, but it is a live data in this case, so bear with me here. But how we get this search result property is that we call as flow, so we convert our channel, our conflated broadcast channel, into a flow. And then we call the debounce operator, which is the key here to keep down so we don't spam our API. So the search delay milliseconds here, I put 300 milliseconds. So when the user haven't typed a new character for 300 milliseconds, we perform a search. And the way we do that is we take, because now we're getting the string from the query into this flow here, into the map latest function. And then I call search API perform search. Now, the nice thing with this one is that if the user will type another character while a search is going on, this coroutine in the map latest function, because it is another coroutine, that will be cancelled automatically for you. So it will never return a result. So then you will just pass on a new one. So you will not get cancelled operations or searches that started what was never completed. And the final one is as live data. So we convert this into a regular Android live data, which is easy to use in the fragments. So first thing, conflated broadcast channel. If you have used RxJava, this is basically the same as a behavior subject. You can configure it a little bit more, which means that it retains the latest value, basically. So a new subscription to this search result here will get the last value. Now, the as live data is an extension function in lifecycle KTX, another reason why you want to use that library. That basically wraps a collection of this flow into a live data object. But not only that, it also makes sure that it is kept around for a little bit longer than the life cycle of whoever is observing this live data. So if your fragment goes in and out of scope and back, it will still be the same object. So I recommend you checking up the documentation for the as live data function. Now, in our activity, we do the following. We use the extension function from the Android KDX that is on the edit text. That's called do after text change. So whenever the text is changed, I get the query channel from my view model, and I call offer. Offer is not a suspending function, so but inside it wraps, it launches a new coroutine inside there. But this means that we don't need to call offer on our channel inside a coroutine. And that is one choice you can do. There is another option here as well, so I'm going to talk about in a moment. But basically, we just give this channel, here's the latest string. Offer will return a Boolean if this worked or not. But in this case, we're actually not interested whether it works or not. If it doesn't work, we're going out of scope anyway, so we can just ignore that. Now, when we want to listen for the results, I have my regular recycler view adapter. And what I do there, I take the search result, which is the live data. I observe that one with the life cycle of this activity, and I call submit list on the adapter whenever I get a new search result. So that's all you need to do to basically implement this instant search. Now, coroutine channels, if you do offer, you can do something like this. But let's say you want to pass in 3 strings. Or 3 ints into a channel. If the last one was successful, it will return true, and then you can do the next one, and you can do the next one. This isn't the practical real-world example, but it just shows how offer works. Now, if nobody is listening to our channel and collecting data, it will return false, so it will not go on to the next one. If you use a suspending function, you can use send instead. So then you can call these just like this, and when send is invoked, it will suspend until someone is collecting. Those are the differences here. So again, depends on which one you want to use. Okay, so let's see how this was solved. We convert the flow in our that comes up in our view model to live data for simplicity. You don't need to expose coroutines up to your fragments or activities most of the time. You can do it if you need to. Also, we're passing down events using a channel. So when you want to generate events in your application code, you usually use a channel. And when you want to listen for events that are coming in, you use a flow. You convert stuff to flow, or you create your own flow. So, coroutine, channel, and flow for events. Error handling. It's important, so in our example, we need to do something like that. And the way to do that has nothing to do with coroutines, but more about Kotlin. Use the sealed class, something like this. You create a type, which is what your flow or your live data will always emit to the UI. And then we have the first class that extends the search result, the valid result, which contains a list of the search results. And then we have 2 objects that represents an empty result when we didn't get any hits, or an empty query when we decided that this query is too short. We don't want to make a search with this short query. And then we have error and terminal error. And the reason I have these 2 will be obvious in a second here. So what we do in the map latest, we just expand that one. We wrap it in a try-catch. Inside it, we make a check if the search string was long enough. If it wasn't long enough, then we return an empty query. If we didn't get a search result, we return an empty result. If we got a valid result, we return that. If we got an IO exception, I mean a network error, we return an error result with that exception. And then finally, after map latest, we add another operator called catch. This will be the terminal catching for any other exception that we didn't catch in the map latest. And there we emit a terminal error, because if we get another exception inside the map latest that we are not catching, that means that the coroutine, the whole flow, will be cancelled. So you need to like restart everything. But this will be like a terminal error that it means that, okay, now I have to close this view and go back or show the user some error message that was completely unexpected. So in our handle search result, we do the following. I see I misnamed the functions there, but I think you get the point. So we check the type, basically, of these, and then we call the appropriate function. Okay. So for error handling, or actually dealing with having a nicer way to deal with the results coming from your flow or your live data that you converted from a flow, use CIL classes for everything. You should, of course, do exception handling properly as well, but it makes the error handling much, much easier. Now, there is a blog post where I wrote about this. You can read more about it. I won't go into details. There is a source code example here as well you can run. This example also contains some code showing how to test coroutines, which I haven't covered yet. And with that, I would like to thank you all for listening, and hope that you find it interesting. I think we have some time for questions. So, any questions? Oh, yeah. Thank you. Did we have a microphone for questions? If there are any questions? No. That's fine. Oh, yeah, one there. Just a second.
Given the maturity of the new infrastructure of the Android X and Jetpack libraries, do you often get conflicts between the third-party libraries you use, which also depend on these components, and your own application code?
Sorry, the last part I didn't get.
The dependency conflicts. So given the maturity state of the Android X and Jetpack, it's quite a recent thing, do you often get conflicts between your code and dependencies and other dependencies which want a different version of that?
If I do get dependency conflicts with the Android, the Jetpack libraries, no, actually, this is, I consider that being a solved issue once they went to Android X. And I know they were expanding on this one, and it's getting better every day as well, so it's like easier to import like entire parts of the application. It does give you warnings properly if you imported one dependency which actually depends on something else where you have a lower version. So yeah, I would say that it's fairly good today. Yeah. Okay. Yeah. No more questions? In that case, oh, everyone.
Sorry, I'm not Android developer, but for error handling, why you use this pattern sending into a CIL class?
Sorry, one.
Why do you use this pattern? Because in my head I have, I think, like using a middleware of interceptor that listen to, for example, to those errors would be maybe.
So you mean this one? Why I pass events down and why I pass them up? So yeah, the middleware that you're mentioning here is the search view model here in this example. That's the kind of the business logic that drives our instant search logic. Now, you could place that on a backend instead. Is that what you mean, or?
Yes. So you send you have a CIL class where error sits, and you send, and it's intercepted by this search model. That's what you said.
So we have this one. Is that what you mean? Or this one, maybe?
Yes, maybe this one.
So yeah, here's the channel where this is a string that the user types in. It gets passed into this function here. And then we basically pass it down into the lower part of the application, which will be in our view model here. So it goes into this channel, and it goes through this flow here. And here it gets passed down to the API. So this is basically just an implementation of the middleware that you're talking about. Okay. I think we're out of time. We need to set up for the next speaker. So thank you all very much for coming. Hope you have a nice day.